Math 1314, Tyler Junior College, Section 2.3, Linear Functions and Slope-Intercept form. If you were watching the previous video, you noticed it cut off mid-sentence. And as I was completing that sentence, I thought I heard my video stop, and I went and checked, and it did. Now, why would it randomly stop? Because I forgot to delete previous videos for the past few days. There were lots of videos, and I ran out of space on my phone. So I had to go through and delete all the old videos so that I can make room for the current ones. So this is an immediate continuation of where I left off. And in the last video, I was saying that if you are writing the equation of a line and you are asked to give the answer in slope-intercept form, set up the equation of the line, which is almost always point-slope form, then solve it for y. That's how you convert the equation of a line to slope-intercept form. Make it say y equals. All right, but I want to talk about how to graph a linear function that is in slope-intercept form, or an equation that's in slope-intercept form. For example, let's say I ask you to graph f of x equals 4/5 x minus 2. Now, we can graph this the old-fashioned way. Make a table of values, choose values to substitute for the x, put them into the function to get values for the y, plot the points, and then connect the dots. When we did that before, I told you that it always works, and it's always the most inefficient approach. The more you know in advance, the less work you have to do. I know a lot of things about this graph. Number one, because it's in the correct form of f of x equals mx plus b, it's a linear function, and hence its graph will be a line. Number two, because it's in slope-intercept form, I know that the slope is 4/5, and I know that the y-intercept is -2. That is valuable graphical information. Can we use it to draw the line? And the answer is yes. Now, one of these values I can put on the graph immediately. The y-intercept is -2. So I can go down to, put a point, and if I wanted to be specific, I could label it 0, -2. But in order to draw a line, I need a second point. And right now I just have a single point, but I also have a slope. Now, how can you use the slope to help sketch the graph of a line? By remembering that slope at its very core, well, at its very core, it's a measurement of steepness. But a little beyond that, slope is defined as rise over run. And since our slope is a fraction, and by the way, it's always a fraction. If it's not, put it over 1 and make it a fraction. But since our slope is a fraction, we can view the numerator as the rise and the denominator as the run. So, from the first point, we can run and rise. So let's think about how this would work. If we run 5, we're going to go 5 to the right of where we are. So let's draw an arrow. I'm going to draw 5 what are called unit arrows. In math, the word unit usually means 1 or length of 1. So these are arrows indicating 1 step. So I'm going to run 5, followed by a rise of 4. Now I have to count carefully because I started out at -2. So let's rise 4 over here first. If I'm at -2 and go up 4, 1, 2 brings me back to the origin, 3, 4. So if I rise 4, 1, 2, 3, 4, where will that put me? Remember, this is not the point 4, 5. When you label a points ordered pair, you always count it off from the origin. So this is 5, 2. And now that I have 2 points, I just have to connect them. Didn't have to make a table, didn't have to substitute any values. I just had to make observations, extract information, and know how to use it. One word of caution. If your slope is negative, then you must choose to give the negative to either the rise or the run. I usually give it to the rise because I always think about a graph moving towards the right with a positive run, if you will. So had this been negative 4/5, and I'm not going to redo the problem, then the rise would have been negative 4, and then after running, instead of going up, I would have gone down 4, put a dot there, and gotten that line, which totally missed both points. So graphing an equation in slope-intercept form is easy if you know how to interpret all three numbers, the numbers on both sides of the slope and the y-intercept. The y-intercept is your starting point. The numerator of the slope tells you how much to rise. The denominator tells you how much to run.